This is how it feels to ride a bike in the harsh Indian climatic conditions when it's so hot outside and it's practically impossible to wear a helmet because of the heat accumulation inside. And the times when cities are breaking their records for the most ever temperature recorded, we decided to do something about it. We made CAVS, that is Cooling and Ventilation Smart Helmet. After going through a lot of designs and iterations, we finally landed upon using a Peltier module for the purpose of cooling. Now we can see the basic CAD design of the model that we created. As you can see, there's an assembly of fan, heatsink, a space for the batteries on top, and also a small slit for the LCD module. Here are the results of some of the analysis that we did. The stress analysis, the strain analysis, and the deformation analysis. And as you can see, the factor of safety and the other values are accordance with the BIS standards. This was the initial Tinkercad model and its assembly in real life. And for the other parts, as you can see, and in this video, as you can see, there's a fan, there's a Peltier module, an LCD display, input, output, connections with Arduino, a relay for the automatically temperature cutting off, and all of this will be going to the backside of this helmet and where we'll be installing this unit. This is the cutting process that we did in the back of the helmet. We cut open this with a cutter and we made a hole of 3 by 3 inch to install the heat sink and the fan assembly in the back of it. And after all this process, our final product looked something like this, where all the components are. As you can see, in our product, we have two batteries in series and three batteries in series differently. These two batteries are responsible for the powering up or Arduino and the Peltier module that is installed inside this. And these three batteries are responsible for the connections of the further circuit. Now, as you can see, there's an external fan. This is responsible for the cooling of the heat sink. This consumes 12 volts. Coming on to the relay module, this cut off the temperatures automatically when it reaches 18 degrees Celsius. This is because of the code that we have coded. Now coming to the Wi-Fi module, this is an ESP8266. This is responsible for Wi-Fi and IoT enabled smart helmet. Now coming to the DTH11, this shows the humidity and temperature of the outside, and this is displayed further on the LCD. Now coming on to the complex circuit that we have here, this is basically the voltage regulator circuit. This contains a capacitor, a voltage regulator, a diode, and other things. This is mainly responsible for the regulation of the voltage throughout the circuit. Now coming on to the LCD module. This will display your temperature of the inside, of the outside, and the humidity. And this, from further we come here to the power distribution circuit. This circuit is responsible for the equal power distribution of all the components in the circuit. This makes sure that all the components in all the circuit are getting the power that they need to run. And finally, coming to the heart of our system, that is Arduino, which basically runs the whole system. And if you are able to see clearly inside, we also have an internal fan where it is connected with a Peltier module, and this internal fan is responsible for the regulation of air inside the helmet. And finally, when we start the helmet, we turn on this plug. As you can see, the sensors are using IoT, and this will show you T1. The T1 is basically the temperature in the inside, and since I'm sitting in a room, so the temperature inside is the 25 degrees Celsius, outside, sorry. And this is further, as you can see, the external fan is running because I've turned on, and this basically cuts off when the temperature reaches below the 18 degrees Celsius. As you can see, it has stopped working, and if you'll note the temperature, this is 17 degree. This is because it has reached below 18 from our specified limit. And the inside fan and the Peltier module are constantly running throughout this operation. And finally, when we tested our helmet on different dates and during the different times of the days, Through these results, we were able to conclude that our helmet was successfully working and was able to bring down the temperatures by up to 10 to 12 degrees. And finally, we were very happy to achieve our results. Thank you so much.